All right, so good evening once again, everybody. Welcome back to you all. And we're just going to try and pick up from where we left off. But rather than starting from exactly where we left off, I'm going to just give a quick recap of the topic to the point where we stopped. And then now from there, we'll continue on to other topics, all right? So we actually, the last topic that we were doing was basic algebra. And so basic algebra, as you know, has to do with learning some rules about algebra, learning in terms of when to apply algebra, why do we apply algebra? And we would have mentioned that algebra is that branch of mathematics that has to do with general quantities. And so for general quantities, we normally don't use actual values, but we actually use symbols or letters to represent these values, all right? Now, in doing so, we will find that there are little changes that we need to take into consideration when we're dealing with algebra. For instance, if we are multiplying in terms of symbols, we generally omit the multiplication sign between symbols, just for simplicity, so as not to overcrowd our symbol with multiplication sign and so on, and so as to simplify and make it a little easier to deal with, we have deleted multiplication sign. So whenever we have symbols that are next to each others, we know that there is an invisible multiplication sign between them. Whenever we have symbols with brackets or even numbers with brackets, there's also an invisible multiplication sign between the brackets and the symbol or the number, all right? So we say that the method of algebra are extension to those using arithmetic. And we know that arithmetic deals with actual calculation of values. So we would perform the 4 basic operations like adding, subtracting, multiplying, and dividing. Now, algebra is that branch of mathematics in which we use letters and symbols as well as numbers to represent quantities. All right. When we write $50, we are making a particular statement. However, if we write $P, we are making a general statement. Now, why we call $50 a particular statement? Because we have an actual value here. We know that particular value. That particular value is 50. But when we say $P, we really don't know what value we're referring to in terms of a particular value. So P here can take on any value at all that we give to it. We can give P value of 1, 2, 3, or any value. So because of that, we say that P makes a general statement, right? So so general here means that P can take any value we choose to assign to it, or P can represent any value that we choose, all right? So we can give P any number we care to substitute. And for this reason, that's why we have to define what we're using these values for, or what we're using these symbols for. So first, we have to say what we are going to use P for, or in the case of X and Y, we have to define it. We have to make a statement by saying, let X be so and so, let Y be so and so. Why is that important? Because the values are general, you know, you can ask two different persons to solve the same problem, but they may use different symbols or different letters defining the same values. So whereas one person may use X to represent a certain value in the question, another person may use Y to represent the same value. So once you say what you're using your values for, or what you're using your symbols to represent, then that's how we actually define what we're going to use our symbols for. All right, so that is important in algebra, that we define what our general values are. All right, so use of symbols. The following examples will show how verbal statements can be translated to algebraic symbols. So we can choose any symbol we like to represent the quantity concerned. Example 1, the sum of two numbers. So we don't know what the two numbers are, but we need to define one number to be a symbol and another number to be another symbol. So let one number be X and the other be Y. Now, it is important that we don't define the two numbers with the same symbols, because we wouldn't be able to make a distinction to indicate that they are different. It is possible that the two numbers can be the same, but it is also possible that the two numbers can be different. So to be safe, we generally will use different symbols to represent different values. All right, so if we let one number be X, the other number be Y, then their sum would give us X plus Y. So 3 times a number, we don't know what the number is, so we define the number. So let the number be N. Therefore, 3 times the number N is simply 3N. One number divided by another number. We don't know what both numbers are. So we say let one number be A, the other number be B. So if we have one number divided by another number, where we have here A would be divided by B. All right, 5 times the product of two numbers. Let the two numbers be M and N. Then 5 times their product, we would have 5 times M times N. Now, because we are dealing with algebra, clearly we can delete the multiplication sign. So instead of saying 5 times M times N with the multiplication sign, we just write 5Mn. And it is understood that they are being multiplied because there's an invisible multiplication sign between them. All right, so these would have been some this would have been an exercise that we would have gone through. I'm not going to spend any time going through this exercise because we would have gone through it already. I'm just recapping the topic so as to refresh it in your mind. All right, so substitution would be the next part of this topic. Now we saw where we have to define our general values using symbols, right? Our symbols generally taken from the letters of the alphabet, and we may use more than one alphabet. We can use the English alphabet, we can use the Greek alphabet, and depending on what level you reach in mathematics, you will see other symbols being introduced from other alphabets. So it is just to kind of give a little bit more distinction with what we're using in terms of operation and what we're using in terms of value, while we have to choose from a wide diversity of symbols. Now, substitution here is when we actually assign some value to the symbol that we are using. So the process of assigning a value to a symbol or a value to a letter is what we refer to as substitution. So there are times when general statements, example, X is assigned a particular value. The process of assigning a numerical value to a general statement is called substitution. Note that multiplication sign must reappear when the numbers are substituted for symbols. So the moment you replace the letters or the symbols, moment you replace them with numbers, and you're carrying out operation. Now, wherever there is a need to put back your multiplication sign, you must put back your multiplication sign. So if you have the letter M times, if you have the letter MN, you know that would mean you are multiplying M times N. So if you give M a value and N another value, once you put in those values in terms of numbers, you have to put in your multiplication sign. So multiplication sign must reappear the moment you have symbols substituted with numbers. All right, so here we'd have looked at these examples. So here you are now given what these symbols represent in terms of values. So wherever we see an expression in the symbols, so we have 2y plus 4, but from our assigned values up here, we see that y equal to 4. So in this expression here, we'd have to replace the y with 4. And then we know 2 brackets 4 is the same as 2 times 4. We carry out the same bed mass, operation, following that sequence in order to get the answer correct. So we work out multiplication before we do addition and subtraction. So 2 4 is 8, plus 4 give us 12. Here again, a second example, we have 3y plus 5z. And so we now going to substitute, we are going to substitute a value for y and a value for z. Now we see that y is equal to 4. So based on the assignment that we are given up here, so x is assigned to, 3 is assigned to x, 4 is assigned to y, 5 is assigned to z. So wherever those values are, we replace them with their numbers. Or wherever those symbols are, replace them with their numbers or their values. So 3y is the same as 3 times 4 plus 5z would be the same as 5 times 5. Because y is equal to 4, so 3 times 4, z is equal to 5, so 5z is equal to 5z. Sorry, 5z is equal to 5 times 5. All right, so carry out our operation. 3 4 is 12, plus 5 5, 25, give us 37. All right, so moving along, here we would have 8 minus x. So we know that x is equal to 3, that gives you 8 minus 3 equal to 5. Y over x, using y to be 4, x to be 3. So we have 4 over 3, which is an improper fraction. Converted to mixed number, we get 1 and 1/3. All right, so here again, another expression in the form of a fraction. So here we have 3y plus 2z in the numerator divided by x plus z in the denominator. So replacing y with 4 and z with 5, x with 3. In the numerator, we get 3 times 4 plus 2 times 5 divided by 3 plus 5. So simplifying the numerator, 3 4 is 12, 2 5 10, the denominator, we simplify that 3 plus 5 give you 8. So we add, for the numerator, 12 plus 10 give you 22. So we have 22 over 8. It's an improper fraction. Now we write that as a mixed number. So we get 2 3/4. All right, so these would have been some exercises that we would have gone through from in previous lessons. And so we would just simply look at the values that are assigned. Here A is assigned 2, B is assigned 3, C is assigned 5. So wherever we have these letters in these expressions, we replace them with the numbers that we assign them with. So we would have done that and then carry out the operation to simplify these. All right, now powers. We know that sometimes you work with powers. Another name for power has to do with the index. And by now we should know what our definition of power is. Now we see that the base is that which we are raising to the power. So the base is the, if you may, the symbol or the number that is being raised to the power. All right. So we should be able to identify what we are referring to as the power. So here the power of A is 3. And why we say that 3 is the power. So 3 here tells you the number of times the base occurs when the base is multiplying itself. So when A is multiplying itself, we count how many times A occurs. So 1, 2, 3. So A occurred 3 times, so the power here is 3. So A times A times A can be written as A raised to the 3rd power. All right, so we say another name for power is index. And if we are referring to more than one index, we call them in the plural sense indices. Now, we can also call index and indices, we also call them exponent, which is just another name. So we are kind of just using big word, small word kind of thing here. So a small word would be power. And then we have index, and a little bit more bigger word than index would be exponent. So it's all part of a language that we use when we're dealing with mathematics, because when you become fluent in mathematics, you'll realize that there are certain terms that are used, certain words that are used, certain conventions, certain rules, certain laws, certain principles. And all of those form the language of mathematics. So you eventually become familiar with the language, and that's when you know you have developed competence in the language, when you can understand what these terms really mean. All right, so here we notice that just in a similar way where we can have our base as a number, we can also have our base as a letter. So 2 raised to the 4th power. So 2 is a particular value, which is raised to the 4th power, meaning when it multiplies by itself, the 2 occurs 4 times. So here y raised to the 5th power, when y multiplied by itself, the y occurs 5 times, and so the power is 5. Now, so it is important that when we are substituting for symbols that are raised to some power, it means that once you replace the symbol with an assigned value, and if the symbol is the base, that assigned value becomes the base raised to the same power. So here we have b raised to the 3rd power. We assign b equal to 5. So now if b is 5, we now have b raised to the 3rd power, which is the same as saying 5 raised to the 3rd power. So we would have, by calculation, we multiply 5 by 5 by 5, we will get 125. All right. Now, it is important to note that when we assign power to values or to symbols, the power immediately above the number so here this power 4 is immediately above the letter n. Now it means that this 4 is only assigned to the letter n. The 4 is not assigned to m, it is not assigned to 8. So it is important that you realize that only the symbol that the power is immediately above, that is the symbol that gets raised to that power. All right. Now there are other scenarios. If we have something looking like this, for instance, so we have 8m, n, and we have brackets to the 4th power. Now, what this is really saying is that each of these terms or each of these symbols would be raised to the power 4. So it means that 8 raised to the power 4, m raised to the power 4, and n also raised to the power 4, right? So only when you have a bracket with the power outside that bracket that the power applies to all of the terms in the bracket. But if you have symbols grouped together where you don't have any bracket that's separating the power, then it's only that symbol that the power is immediately above. Only that symbol takes that power. All right, so I hope everybody is clear on that. Let me just see your hands if you're understanding very well what I just explained about this. All right, very good. All right, so with that said, moving along. So note that it is only the symbol n which is raised to the power, to the 4th power. So here, thus 8mn to the 4th is equal to 8 times m. Now, n is the only symbol raised to the 4th power, so n has to occur 4 times in this simplification. All right, so here, if we are to simplify based on these values that are assigned to P and Q, so we see that P is assigned the value 5, Q is assigned the value 4. Therefore, we know wherever we see P, we are going to replace it with 5. Wherever we see Q, we're replacing it with 4. And because this is a product, the multiplication sign must reappear. And then now we continue by expanding the powers. And then now we multiply out everything, we get our final value. Here we would have gone through these already. We would have worked these exercises in class. So moving along. Now this was the final thing that the topic or subtopic that we looked at in dealing with basic algebra. And so we started off talking about binary operation. Now, when we think about operation, we know that operation tells you what you're doing to the numbers or to the symbols. So the instruction that tells you what you are to do